Hello my dear EAPCET aspirants. So we are very close to the AP EAPCET, right? So due to that reason I have brought top 30 inorganic questions for EAPCET entrance exam. Okay, so this session includes top 30 inorganic questions including the PYQs also. Okay, so now let us start our session. So I would like to ask you that, so before starting the session, just click on the like button first, so that it will be very like boosting for us. Okay, so let's start our session. The first question here given is match the following. So list 1, list 2 are given, so we need to match accordingly. Okay, so these are the electron gain enthalpies of these elements. Okay, so now which element corresponding to its which of its value. So now tell me which one is having more electron gain enthalpy, which is having more tendency to gain the electron in the halogens family. So we have fluorine, chlorine, bromine, oxygen, like that now. So in that, so chlorine will be having more electron gain enthalpy than fluorine. Okay, the highest electron gain enthalpy value is for chlorine in the periodic table. It means it is having more negative. So which one is the more negative value here? So for chlorine 4. Okay, B4. So where do we have B4? So here we have only B4, right? So we have only in the first option, that's it. So we got our answer, directly we can choose. Okay, very simple, right? So I told you in the complete periodic table which is having more negative electron more tendency to gain the electron, so it will be for chlorine. That's why it is having more amount of energy is releasing, that's why it is having negative symbol here, negative symbol for this electron gain enthalpy, which is indicating that it is having more tendency to gain the electron, therefore it is releasing more amount of energy. So B4, so B4 is done. Okay, we do not have any other option with that particular value, right, in any of these, so we can go with option B. Okay, the next fluorine option A here, fluorine having minus 328, so A2, yes, that's it. Okay, when it comes to oxygen family, sulfur is having more than this oxygen. So oxygen is the least electron gain enthalpy, it is having least tendency to gain the electron in the 16th group elements. Okay, and sulfur is the highest in that 16th group. Okay, so therefore the next highest value, that is D3. Okay, D3, yes. So C1, yes, this is the correct one. Okay, let's go for other question. If the first ionization enthalpy values of sodium, magnesium and silicon are respectively. Okay, so this is also very important and interesting question here. Look here, so they given sodium, magnesium and silicon. Okay, so here one element got missed here, so let us discuss here what they are saying respectively with the values 496, 737 and 786. Okay, 786. The first ionization enthalpy of aluminium, yes. So what is the element here missed? So aluminium is missed. So what is the ionization energy for this? So the ionization energy values of other elements are given, but this missed element aluminium ionization energy is how much they are asking. So what do we know for this period elements? So like sodium, what are the elements we have in the third period? Sodium, next magnesium, next aluminium, next silicon, next what? Silicon, next phosphorus, sulfur, these things now, and then next chlorine. These are the elements we have. Okay, so now how do we arrange them? So how do we arrange them based on their ionization energy? We know halogens are having maximum ionization energy, right? Then next phosphorus, due to its half-fill electronic configuration, it is having more than this sulfur. Okay, then next silicon, and the next magnesium, not aluminium. Okay, so least is for sodium. So now the aluminium is having value, its ionization energy value lesser than the magnesium and more than the sodium. Yes, it means magnesium, sodium. So the value which lies in between these two values, between 496 and 731, we need to choose that value for this aluminium. Yes, so look here, 731 lesser than the 731, more than the 496. 496. So this is the only value which is lying in that range now. So we have to go with this option. Hope it is clear how simply we are easily we are able to solve this kind of questions, right? So these are very important now. Okay, so let's move further. See, from periodic classification, you need to focus on periodic properties more, like ionic radius, atomic radius, isoelectronic species, then next ionization energy, electron gain enthalpy, right. So these are the things, electronegativity, these are the things you need to focus. And the next one is oxides. Oxides also you need to focus, which is acidic oxide, which is basic oxide, like that. See, nitrogen has more ionization enthalpy and electronegativity than beryllium. Yes, this statement is correct only now, right. Okay. Now chromic oxide and boric oxide is given, or boric anhydride is given, both are acidic oxide. Yes, both are acidic oxides. So both statements are correct. So both statements are correct. Both statement 1 and 2 are correct. So you can go with option number 1. Okay. So we have one more question here. Arrange the following with the property mentioned in the brackets. Okay. So which are the following sets elements do not correctly match, do not correctly arranged with the property mentioned. Yes. So tell me whether this property is electron gain enthalpy. Yes, we already discussed. I told you sulfur is the highest electron gain enthalpy, having more tendency to gain the electron. That is what electron gain enthalpy is more for sulfur, I told you in the first question itself, and least for oxygen, I told you. In between we will be having sulfur, selenium, tellurium, like that we will be writing in this in between this. So sulfur, selenium, oxygen is the perfect answer. Yes, this is correct only, but they are asking about not correct. Okay. Next, electronegative, highest electronegative element in the periodic table is fluorine, then oxygen, then next nitrogen and chlorine. Yes, this is also correct. Okay. So order is correct. Metallic character. Yes, tell me metallic character, which is whether it is correct or not. Yes, it is correct only. Down the group metallic nature increases, and from left to right metallic nature decreases. So lithium here, sodium here. So sodium is having more metallic nature than lithium, because down the group metallic nature increases, right. These are first group elements, right. This is correct only. And the next, from here to here, from second S block to P block, metallic nature decreases, right. So sodium is having maximum metallic nature, then lithium, then least is for aluminum. Yes, this is also correct. Okay. What about metallic radius, they are asking, not metallic nature. Okay, that is also true. Let's discuss about this metallic nature here. Yeah. So in this metallic nature, so what I told you, so lithium, sodium, potassium, rubidium, like this we will be writing now. So down the group I told you metallic nature increases. It means potassium should have more metallic nature than this sodium, but the order is given in the wrong way. So you can say this option D is arranged in the incorrect way. So that is what we need to choose, because they are incorrectly matched. So which is incorrectly arranged? Option D is incorrectly arranged. So you can go with option D. Okay. So option metallic radius, it is correct only now. Option C is correct only now, because down the group metallic radius what happens? Size increases now. So sodium is having more size than this lithium. That is correct only. So from left to right radius decreases. So that's why aluminum is having lower size. Okay. That is correct. So which is incorrect here? Option D is incorrect. So that is what we need to choose as the answer. Next, consider the following. The first ionization enthalpy of the first three elements of third period is. Okay. So yes, again repetitive question now. So I hope you can able to solve this question, right. So take this, mention in the comment box by putting 51, question number 51, and I am expecting answer from your side for this particular question, because already we have did similar type of question just now. Okay. So I can expect from your side only. The answer for this question will be given in the comment box. So give a try from your side, then I will be explaining it. Okay. Next, hybridization of boron in this, and tin here, and mercury here. What is that? So how can we do for boron here? So boron belongs to 13th group element. So 3 unpaired electrons are there like this. So fluorine, fluorine, fluorine. Okay, sigma, sigma, sigma. 3 sigma bonds, 0 lone pairs. So 3 sigma bonds means it is sp2. Yes. So this is sp2 hybridization, and here SnCl2, what is it? 14th group element, 4 plus 2 by 2. So 6 by 2, 3, again sp2. This is also sp2. Okay. Now for this it is sp. So sp2, sp2, sp. So first option is correct for this question, right. So for more clarity on this hybridization concept, I have made a very useful and very easiest with very simple explanation in valence shell electron pair repulsion theory. Yes, a dedicated video is available in the playlist, go and watch it. Okay. After this again belongs to this question also from the hybridization only. So you can get all these questions without any confusion. If you watch it more clearly, then you will get everything about this. So SF4, so sulfur 16th group now, so 6 plus 4 monoatomic atoms are there, fluorines by 2, so 10 by 2 5. So if it is 5 is a hybridization number, so it means 5 sp3d, so 1 3 4 plus 1 5, so like that you can say. Okay, so out of this 5 surrounding atoms are 4, so it means surrounding atoms, it means bond pair electrons are 4, one is lone pair electrons which is present on the sulfur. Okay, so 4 bond pair, 1 lone pair. So in trigonal bipyramidal geometry 4 bonds are there and 1 lone pair is there, so that structure will be called as seesaw. What is that? Seesaw. Okay, now for example for this halogen ClF3, chlorine is 17th group element, so we can say 7 valence electrons are there in the chlorine and 3 surrounding atoms. So 7 plus 3 10 by 2 5, again 5 means, so 5, but here surrounding atoms are only 3, so out of 5 3 are surrounding atoms bond pair electrons and remaining 2 will be lone pair electrons, right. So what we can say, it will be in trigonal bipyramidal geometry. So if 3 positions are occupied and 2 positions are surrounded by just by lone pair electrons, then we can say it is T shape. What is that? T shape. So it will be T shape. And BRF5, if you do this, so it is also 7 plus 5 12 by 2 6. So octahedral geometry with only 5 bonds 1 lone pair, so it will become square pyramidal here. So C4 and XeF4 becomes square planar, that's it. So A3 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 B1 B1, so option D is correct for this question. Okay, so you can choose this as the answer. Hope it is clear now, no confusion, right. So how simply we can, like how easily we can solve this kind of questions. Okay, so now again from molecular orbital theory, yes, there is a special video on molecular orbital theory. If you watch it, so you can have that confidence that you can able to solve questions, any question from molecular orbital theory in the exam. Okay, so I suggest you to watch again molecular orbital theory concept from the playlist. Okay, so from chemical bonding you should not skip valence shell electron pair repulsion theory, then next molecular orbital theory, both you can go and watch it. Okay, so then next, which does not exist. Okay, if bond order becoming 0, if for any species, if bond order is 0, so that molecule won't exist. Okay, so there should be some value for bond order, then only that will be existing. Okay, so now here H2 plus is there, so here how many electrons are there? 1 electron will be there now. So 1 electron, so bond order formula is what? Half into number of bonding molecular orbital electrons BMO minus ABMO electrons. So this is a formula we have to use here, half into number of BMO minus ABMO, this is a formula you need to use. Okay, so how many BMO electrons? 1 bonding molecular orbital electron, anti-bonding 0, so half into 1, that will be half only 0.5. so for H2 it is 0.5. Okay, for this it is 0.5. So for helium He2 plus means, helium means atomic number 4, atomic number 2, so 2 atoms means 4, so 4 electrons are there, so plus 2 means 2 electrons you have to remove, so remaining only 2 electrons, so that lies in bonding only now. So 2 minus 0 by 2, so that will be 1, so bond order here it will be 1. So if they have some value like this, then they can exist. If the value is 0, they won't exist. So for lithium, here how many are there? So lithium means atomic number 3, 2 just 6. Okay, so 6 electrons plus minus 2, so again minus 2 charge is there, you need to add 2 more electrons, so it will becoming 8. So 8 electrons means what? Sigma 1s 2, sigma star 1s 2, sigma 2s 2, sigma star 2s 2. So all these 4 orbitals are filled with 2 electrons, so therefore cancel out each other, so bond order 0, so it won't exist. Okay, so whenever the bond order 0, so similarly for neon also bond order will become 0, that won't exist. Okay, so for helium also it will be bond order will be 0, so it won't exist. Okay, so where do we have? Yes, here, here, here. Yes, so option B is correct. So why not beryllium 2? Just will you tell me that? So for Be2, so atomic number is 4, so 4 to the 8 and minus charge is there, means you have to add 1 electrons. 8 plus 1 9, so again 8 electrons cancel out each other, the 9th electron will remains, so that will, due to that reason it will become, bond order become 0.5. Okay, so this molecule exists, this will exist, this will may also exist, but these 3 won't exist, so choose the option 2 as your answer. Okay, so how many of the following species have same bond order? Yes, so you just count number of electrons. Okay, so if you count number of electrons, for example, if 14 electrons are there, so if 14 electrons are there, so you can get the bond order 3. If 13 electrons and 15 electrons are there, so both of them have bond order 2.5. So if 16 electrons are there or else 12 electrons are there, so for both of these bond order will be 2. Okay, so like this you can simplify. Again here 11 electron, here 17 electrons, bond order will be 1.5. Here 10 electron, here 18 electron, bond order will be 1. Like that, so you need to count the number of electrons and you can get the answer. For example, here I will be taking only one option, after that remaining you can consider and you can tell me the final answer. So which of the following have bond order 2? See here C2 molecule, how many electrons are there? C2 means carbon atomic number 6, 2 is 12, so 12 electrons are there. If 12 electrons, what I told you, 2 is the bond order, so for this it will be, bond order will be 2. Okay, so here you can come oxygen, so 16 electrons are there, here 12 electrons means 2, again 16 electrons means also 2, so you can take like this. Okay, this is 2, this is 2, again boron means atomic number is 5, 2 the 10 with minus 2 charge, so add 2 more electrons, so 12 becoming 12 electrons, again that will also bond order 2. So like that you need to count number of species with unpaired, number of species with the same number of having bond order 2. So take it as 104, take it as homework and tell me the answer in the comment box. Okay, hope it is clear how can we do that, right? Next, the bond order is inverse measure of what? See, bond order, more the number of bonds. For example, in N2 molecule, if I write, so N like this we are writing now. So here we have represented 3 bonds between 2 nitrogen atoms. So bond order of N2 is 3. So it represents number of bonds between 2 atoms in a molecule, that is what the bond order. Okay, hope it is clear up to here. Now what is my question is, what they are asking, bond order is inverse of what? Okay, so more the number of bond orders, more the number of bonds between the 2 atoms. So what happens, these atoms will come very close to each other now. So when they are coming close to each other, what happens, like more the number of bonds, see as number of bonds increases, see this is one bond, this is second bond, third bond, like that. If more the number of bonds, atoms are coming close, right, so the distance between the 2 atoms decreases. So bond order, if bond order increases, bond length decreases. Okay, so bond order increases, bond order increases, bond length decreases. So that is what the inverse. Okay, so whereas bond order increases, bond angle also increases, you can remember that. And bond dissociation energy, so this is a general statement I am saying, not all the time. So next, bond dissociation energy is, if the more the number of bonds, more is the energy required to break them, right? So more bond order, more bond dissociation energy, this is directly proportional, and more is a bond order, more is the stability for that particular molecule, so this is also directly proportional. Okay, the only the inverse measure is with the bond length, not bond angle, it is with the bond length. So what you need to choose, option 1 will be your answer. Okay, hope it is clear how we are able to do this, right? Then next, let me change the color of the pen. Okay, what about this correct sequence of bond order? Again I told you just now, count the number of electrons. If 14 electrons are there, what I told you, 14 electrons, bond order 3, if 13 electrons, like that. Okay, so see, whenever you have 14 electrons, bond order is 3, so 13 and 15, so bond order is 2.5, 12 and here 16, bond order is 2, like this. If 17, bond order is 1.5, if 11, bond order is 1.5, again 18, bond order is 1.0. Now here count the number of electrons. See, when I say O2 molecule, bond order electrons are 16 electrons means bond order is 2. So for this bond order is 2. For this 18 bond order is 1. So for this 16 plus 1 17 bond order is 1.5. This is 2.5. That's it. We got the answer. So make the proper arrangement out of this and you will get the answer. So O2 plus first, O2 plus, then next O2, next O2 minus, O2 2 minus. This is your answer. O2 plus, yes. So we have option B as your answer, right? So I hope it is clear how we are able to solve this kind of questions, right? So let's move further. Which are the following sets are correctly matched? Okay, so B2H6. So B2H6 having diboron we are saying now. So again remember guys, so this question is also as a homework for you. So why I am giving this homework means, see I have in the playlist, if you see there is something called Golden Minute Series GMS. So where I have dedicatedly made a 10-minute video for this diboron concept, because for EAPCET diboron is one of the favorite topic. Okay, so they will be giving at least one question from this diboron topic. So you can go and watch it. So in that video I have provided maximum things that are required for EAPCET from the diboron topic. So after watching that you can able to solve these questions easily. So I will be leaving this question for you. So I want your answer in the comment box for this. Okay, so once you can watch this diboron topic in Golden Minute Series, you just search diboron by Ajay Sir. So you will get in the YouTube. So you can watch it. Okay, so which are the following set are correctly matched? Now tell me. So B2H6 is electron deficient because it is having 3 centered 2 electron bonds, right? Banana bonds we are saying now. So it is having electron deficiency, 12 electrons only present in that. Okay, so now ammonia NH3 having one set of lone pair, one set of electrons, pair of electrons. So that is electron rich, not precise. See, if all the electrons around the carbon are involved in the bond formation, we can say that is sufficient or precise. But here electrons are like set of lone pairs are present, right? So I can say electron rich, not precise. Okay, so that is not correctly matched. Okay, first one is correct. So here water on this oxygen lone pairs are present. So this is electron rich hydride. So 1 and 3 are correct. Only 1 and 3 are correct. So option C is correct. Okay. Let's move further. The correct set with respect to halides of group 14 are. Okay. So for group 14 again important topic it is CCl4 cannot be hydrolyzed, but here they are saying both CCl4, CLI, silicon tetrachloride undergo hydrolysis. No, this won't undergo hydrolysis, but CCl4 can go undergo hydrolysis. Okay, so water, whenever we are adding water, so this will be act as nucleophile and it will be act as electrophile, and this lone pair electrons of oxygen enters into the empty orbital of this silicon. Okay, empty d orbital of silicon, so that this chlorine will goes out. Like that we will get silicic acid. Silicic acid means SiOH 4 times. Okay, we will get this as a product. Okay, so this is incorrect because both they are saying, but CCl4 won't show this hydrolysis reaction here. So this is incorrect. Okay, so germanium tetra coordinated compound here, like 4 ligands, 4 halogens are there. So they are saying germanium like GeXeX4 is more stable than GeX2. Okay, X means let us say any of these halogens. Okay, so you know the concept here on these two topics is what? Very important one is, it is inert pair effect. IPE I am writing inert pair effect. So what it is saying is, so down the group, see what is the maximum number of valence electrons in the halo, like this group 14 elements for this group 14. So 4 valence electrons are there. So if by losing 4 valence electrons, it can show maximum oxidation status +4. So now we have carbon, silicon, germanium, tin, lead. Okay, I am writing like this. So if they show +4 by losing 4 electrons, we can write like this, and by losing only 2p electrons, okay, so it can show +2 oxidation state, Je +2 and Sn +2 and Pb +2. Okay, these are the 2 possible oxidation state. Now out of these 2, what happens for this stability of this +4 and +2 oxidation state? See down the group, +2 oxidation state stability increases and +4 oxidation state stability decreases. So whenever we are seeing +4 oxidation state, Ge +4 is more stable than this tin and lead with the +4 oxidation state. Okay, and see here, this is also Ge germanium with 4 halogens is more stable than this 2. So this statement is correct only. So +4 oxidation state stability of Ge is more stable than the +2. Okay, next for these PbX4 and PbX2, like F2, F4 you can take. Okay, so F4 is less stable than F2. Okay, that is what you can understand. So why? Because of inert pair effect. So which is more stable? PbX2 is more stable. So PbX4 is less stable. So third one is correct, second one is correct, and first one is incorrect. 2 and 3 are correct. For this you can choose option 3. So what do we mean by inert pair effect? So due to, see, the inertness of ns pair electrons to take part in the bond formation. It means, so for 14th group we have ns2 np2 electronic configuration na? So these electrons do not participate in the chemical reaction. That is what the inert pair effect says us. Only these p electrons will take part in the chemical reactions as we move down the group for 13th, 14th, 15th groups. I mean for these p block elements. Okay, so only these p electrons, whatever the p electrons are there, they will participate in the chemical reactions. Okay, as we move down the group. Okay, so that kind of nature will be increases as we move down the group. So the bottom elements will show only lower oxidation states like +2, +1, but not this maximum oxidation state like +3, +4. Okay, I hope it is clear, right? So let's move further. The BOD values of pure water and highly polluted water are respectively. So more is the BOD, more polluted water it is. Okay, so biological oxygen demand. So if it is demanding more amount of oxygen by the bacteria, what we can say, the water is more polluted, it contains more organic wastage. So in order to oxidize that, so bacteria requiring more amount of oxygen. So that is what we can understand. More BOD, more biological BOD value, so more it is polluted. Okay, so BOD values for pure water and highly polluted water. So if the BOD value if it is greater than or equals to 17 ppm, then we can say water is highly polluted. Okay, so now if BOD value is less than 5 ppm, so less than 5 ppm we can say this is pure water. So if it is less than 5 ppm pure water and greater than 17 ppm, can say more polluted water. Okay, so more BOD more polluted. Okay, you can remember like that. Okay, more BOD value, more it is polluted, you can remember like that. So which is one is having this kind of options? So for pure water, so BOD will be less than 5. So BOD is less than 5 here. Okay, and for more polluted water, it is greater than or equal to 17 ppm. You can go with option 2. Okay. Next, this is from metallurgy. Okay, so what is the methods we will be using here? So for titanium and zirconium will be using Van Arkel's process B3. So B3 only this option you can directly choose. Okay, we will verify with other options also. Mons process, nickel will be for Mons process, yes. And the next for copper, silver, for silver and like other precious metals, what we will be using? We will be using electrolytic refining, D1. So D1, yes, D1. The next what I told you, nickel, Mons process, yes, you can go with this germanium zone refining. Okay. So I hope it is clear how we are able to solve this question. See, from metallurgy, just open any of your book. So just look into the ores. What are the ores given in the book? For example, siderite if I say. So what is the siderite formula? FeCO3. Okay, like that. Okay. So what is the like they will be giving some ores and they will be giving some formulas. We need to match them. The name and the formula we should match. Okay, and which are the following is carbonate ore, which are the following is sulfate ore, which are the following is more suitable for extraction of iron, like that they will be giving different minerals and they will be asking us to find their formulas matching, like that. So just to go through the basic thing like names, formulas, that's okay. This is the main thing. And the next, refining process. For which metal, what is the refining process? For example, here for nickel we have seen Mond's process. For titanium we are saying this one, Van Arkel's process, like that. Okay, so we need to remember these things also. Okay, next, which are the following compound, which among the following having diamagnetic? Okay, out of this, which are diamagnetic, which are paramagnetic, they are asking, you know. Okay, so remember here, so diamagnetic and paramagnetic, okay, which are the following compounds are diamagnetic. Okay, so N2O3 is diamagnetic. See here on NO, if you consider, here we have one odd electron, so that it will be paramagnetic. Okay, so if it is containing NO and also NO2, NO2 also, look here, nitrogen having 5 electrons now, but oxygen is divalent, so 2 oxygens are attached. Okay, it means one unpaired electron is remaining. So these two are what? Paramagnetic substances. If they are present in the options, those will definitely paramagnetic only. Okay, so here in this option we have, so this is a this is paramagnetic and this is also paramagnetic substance. So out of these we have to look into these two options. Okay, so which among the following are diamagnetic? Okay, so now here N2O4 is okay, these are fine. Okay, so I can go with both of the options are correct. If they are asking about diamagnetic, yes, both of these options are correct. Okay, if they are asking only about paramagnetic, so C is the correct option. This is for paramagnetic. Okay, and these two things are for diamagnetic. Okay, so both are diamagnetic. I hope it is clear how we are easily solving those questions, right? Okay, so decreasing order of number of ionizable hydrogens in the following molecules. Okay, so for this, what is the structure of this compound? So orthophosphoric acid, okay, like this, oxo acids of phosphorus, it will be from P block elements. So these 3 hydrogens are ionizable, so it is having valency factor 3, and for this valency factor is 4, you just write them like this. Okay, so if you calculate the oxidation state, you will be getting +4 for each of the phosphorus, like this. So how many ionizable hydrogens are there? 4 are there. Okay, so 4, 3, so 4, 3, next here it is 2, here it is 1, so 2, 1, yes, option B is correct for this question. Okay, the yellow color of chromate ion and orange color of dichromate ion is due to, yes, so if you say chromate and dichromate, so dichromate means what? K2Cr2, potassium dichromate means K2Cr2O7, we are writing now. So chromate, let us say, dichromate, let us say, we will write like this. So now here chromium is having +6 oxidation state. So chromium here, if there is any d orbital electrons, we may expect for dd transition, but there is no d orbital electrons because it is in maximum oxidation state, it is having d0 electronic configuration. Okay, so in this case, to this chromium +6, so these oxide ions are there now, so these are the ligands we can say. So they will transfer this charge into this metal. Okay, so this phenomenon is known as charge transfer phenomena. Okay, so KMnO4, potassium permanganate, okay, and potassium dichromate or chromate, all this shows color due to the charge transfer phenomena. Especially what type of charge transfer? From this ligand to metal charge, this charge is transferring now, so that is why we should call it as ligand to metal charge transfer. Okay, hope it is clear. Option B is correct for this question. Okay, then next, the spin only magnetic moment value for the complexes. So 2 complexes are given. Again, I have made a special video on metal, this coordination compounds, metal complexes, so you can watch it for more clarity. Okay, so here manganese having +3 electronic configuration, +3 oxidation state. So manganese we know having 25 atomic number, so 3d5, 4s2, but +3 means how many electrons we need to remove? 4s0, 3d4. Okay, so 3d4, right? So 3d4 means if we want to write like this orbital representation, so 4 electrons, 1, 2, 3, 4 electrons are filled. okay. So it is having +3 oxidation state. So now cyanide is strong field ligand, so this electron will pair up here, so 2 unpaired electrons are there. If 2 unpaired electrons are there, you just use N into N+2 Bohr magneton formula. So N value is 2, so 2 + 2 4 into 2 8, root 8 will be getting, okay. So root 8 means it is around 2.84 here we have, okay. So 2.84, here also we have 2.84, okay. So then next, here in the cobalt it is having D6 electronic configuration, all the electrons are in T2G set only, EG set electrons are 0, so therefore all electrons are paired up, therefore it will be having 0 magnetic moment. So option 1 is correct for that, okay. So the next, increasing order of the crystal field energy. So this is again from what? Splitting order ability. I hope I have given an order here, okay. I will see, okay. If not, you can go and check in the coordination complexes complete lecture, okay. So I have covered in the short period complete, like I have taken many questions, different examples, and I covered everything, so you can watch it, okay. So crystal field, arrange the following in increasing order of their crystal field splitting energy. So we know all 4 cases cobalt is in +3 oxidation state, so we cannot define with respect to oxidation state of cobalt in this case because all of them are having same, but cyanide, water, fluoride, ammonia, so ligands are different. So which is the strongest ligand here? Strong field ligand is cyanide, after this ammonia. So this will be splits them to the greater extent, therefore its splitting energy will be more, therefore the crystal field splitting, okay. So for which it is more? For 3 it is more, so 3 2, the next 3 2, yes, that's it. So we do not have any options like that, no? Only one option is a 3 2, so you can choose that, okay. Next 3 2 1, yes, water is more than the halide, fluorine, okay. So this already we did, this is also we did. Then next, which of the following is not correct about the carbon monoxide? So carbon monoxide having more binding capacity towards the iron when we compare with the oxygen, okay. So carbon monoxide, when it binds to the iron in the hemoglobin, forms carboxyhemoglobin, okay. This is correct only, okay. It reduces oxygen carrying ability to the blood or of the blood. So yes, this is also true because when it is binding, so the binding capacity towards the oxygen will be decreases, okay. When it is binding towards carbon monoxide, its binding capacity towards the towards the oxygen will be decreases, okay. For hemoglobin, iron in the hemoglobin, the carboxyhemoglobin is less stable than the oxyhemoglobin. No, the carboxyhemoglobin is more stable than the oxyhemoglobin, okay. So this option is incorrect. It is produced due to incomplete combustion. Yes, carbon or hydrocarbons upon incomplete combustion we may expect for production of like CO gas may carbon monoxide may produce, okay. So 1 2 4 is correct, they are asking for not correct, so option 3 is not correct, you can choose that, okay. Sucrose upon hydrolysis gives what? Alpha D glucose and beta D fructose. So it will give alpha D glucose and beta D fructose. And here my question is, tell me whether sugar is reducing sugar or sucrose is reducing sugar or non-reducing sugar, reducing or non-reducing, okay. So just tell me in the comment box for this, okay. CO plus H2, so this mixture is called synthesis gas, okay. So A3, okay. Temporary hardness is because of bicarbonates, B1, so B2H6 is electron deficient, we already seen, so C2. See, I told now B2H6, diboron is one of the favorite topic for EAPCET exams, okay. H2O2 is non-planar structure. So as per that A3 where do we have? A333, okay. Temporary hardness 1, B1, so B1 only in the first option, you can go with 1. Next, number of protons, neutrons and electrons in lutetium, okay. Atomic number is 71. So I can say number of protons gives its atomic number, so it is 71. So number of neutrons means what? Neutrons plus protons gives its mass number, okay. So mass number is 175, so protons are 71, then neutrons are how many? So neutrons becomes what? 175 minus 71, that is how many? 104, so 71 104 we got, okay. So the next what we have? electrons. Electrons are how many? Same number of electrons and same number of protons. So option 1 is correct. I hope every question in the discussion is very clear, right? So if you have any confusions or anything not able to understand properly, you can write in the comment box. I will be explaining there. So feel free to ask your doubts in the comment box. Yes. So thank you for watching. Happy learning.